In this video, I'll go over question 2 in exam 1. Question 2 reads, I was driving my Prius when suddenly I saw a cow start to cross the road. My speed at the time was 15.0 meters per second. I continued at this speed for 0.510 seconds before I stepped on the brakes. Then the Prius decelerated at 5.10 meters per second squared. In part A of the question, we're to draw a motion diagram of the Prius below, using multiple velocity vectors to show how the velocity is changing. On the diagram, draw the acceleration vectors for each region of constant acceleration. Okay, so I've already shown that below. Over on the far left of the drawing, right here, this is where I see the cow, and I call that position x0. And I show 3 frames after the x0. And at 2 of these frames, I denote that the acceleration is 0, and I also indicate that the velocity is to the right and is constant. Then, at this point, x1, that's where the brakes are turned on, and from that point on, there's a constant acceleration to the left. And it's also, this constant deceleration is also reflected in the velocity vector, which is getting smaller and smaller with each frame, until finally I reach a stop at time t2 and position x2. So that's how I wanted you to draw your motion diagram for this problem. In part B, we want to know how far I traveled before I stepped on the brakes. That is, what is the distance between position x0 and x1? Well, I know what the time is at x1, t1, that's given. t1 is 5.510 seconds. And I know that the velocity is constant during this time. And that is 15.0 meters per second. So to define the displacement, x1 minus x0, that's simply equal to the velocity times the time. t1. So this is the product of 15.0 meters per second times 0.510 seconds. And then I put that in the calculator and I get 7.65 meters. In part C, how long after I hit the brakes did it take to come to a complete stop? Well, I know what the displacement, no, I do not know what the displacement is, but I know what the final velocity is. The final velocity is 0. and I know what the initial velocity is. It's 15.0 meters per second. And I know that the acceleration is equal to minus 5.10 meters per second squared. So I'll use our equation 1 from our set of 4 kinematic equations with constant acceleration, and write that V final is equal to V initial plus the acceleration times the time. So we're after the time. The time is equal to V final minus V initial over the acceleration. So that's 0 minus 15.0 meters per second over minus 5.10 meters per second squared. And I plug that in my calculator, and I get 2.94 seconds. Now, let's do part D. What is the total distance I traveled after seeing the cow before coming to a stop? That is, what is the displacement between x2 and x0? Well, that's equal to the displacement between x2 and x1 plus the displacement between x1 and x0. Well, we found the displacement between x1 and x0 in part A. That was 7.65 meters. So we need to find x2 minus x1. So what's known? We know what x1 is. X1 is 7.65 meters. We know what V2 is. V2 is what we called VF up in part C. I'll just write it as V2 is equal to 0. That's where we come to a stop. We know that V1 is equal to 15.0 meters per second. And we know the acceleration is equal to minus 5.10 meters per second squared. And we know what the time interval is between x1 and x2. That time interval, delta t, is equal to 2.94 seconds. So we can use either equation 2 from our list of kinematic equations with constant acceleration, or equation 4. Let's use equation 4. It says that the displacement, which is x2 minus x1, is equal to the average velocity times the time interval. So that's V2 plus V1 over 2 times delta t. So this is 0 plus 15.0 meters per second over 2 times the time interval 2.94 seconds. And then we solve for this with our calculators, and we get to 3 significant figures: a displacement of 22.1 meters per second. Then to answer the question, what is x2 minus x0, we add this 22.1 meters per second to the displacement x1 minus x0, which is 7.65 meters. And find that the answer to part D is 29.8 meters. And that concludes this video.